Hey everyone, welcome back. This explainer is brought to you by Forge College, and I am super excited to get into today's topic. So in our last lesson, framing a comparative analysis of web eras, we built this, beautiful theoretical framework, right? We looked at Web 1, Web 2, and Web 3, and we mapped out the boundaries based on who controls the data and who actually holds the governance authority. But today we're putting on our hard hats. We are stepping out of the clouds of qualitative theory and we're walking right into the engineering lab. We are going to build hands-on, concrete measurements. Today's explainer is all about operationalizing evaluation metrics.
Okay, let's dive into this. How exactly do you measure a vibe? Well, spoiler alert, you can't. There is literally no way. As much as we, love casually talking about the feel of decentralization or the vibe of data sovereignty, you absolutely cannot build a capstone comparative analysis on vibes. It's like an engineer trying to build a suspension bridge based on a feeling. It's just not going to hold up. We need concrete data. We need the equivalent of literal tape measures and voltmeters to quantify these abstract concepts, just to make sure our assessments are consistent, reproducible, and actually based on hard evidence.
Think of our agenda today as our engineering project manifest. We're going to go step by step. First, we'll move from theory to metrics. Second, defining your indicators. Third, normalization and weighting. Fourth, scoring real-world cases. And finally, triangulation and trust. Let's get to work.
Part 1. From theory to metrics.
In that previous module, we laid out some really great high-level criteria for evaluating web technologies. But now, we actually have to convert those into hard data. And what we're looking at here brilliantly illustrates the exact transformation we have to make. On one side, we've got qualitative high-level criteria, things like decentralization or governance. And hey, those are great for theory, but they are absolutely terrible for spreadsheets. So, on the other side, we translate those into observable indicators. Decentralization becomes something you can actually sit down and count, like validator concentration. We're essentially taking the theoretical architecture of the web and pinning it down with concrete, codifiable metrics.
So what exactly is an indicator anyway? Well, by definition, it's a specific, observable, and measurable variable used to assess the state of a broader criterion. Basically, it's your foundational unit of evidence. And an indicator doesn't always have to be some continuous numerical value. It can be categorical, it can be ordinal, or even just a simple binary yes or no. Like, hey, does this platform have a data export tool? Yes or no? But the absolute golden rule here, it must be strictly, undeniably measurable by anyone who looks at it. Moving on to part 2, defining your indicators. Let's set the rules. Because you see, simply picking a name for an indicator, that's not enough. We have to define exactly how we're going to calibrate our tools. Think of this matrix as our ultimate measurement blueprint. It maps our big criteria like decentralization, data sovereignty, governance, economics, directly to an indicator, a specific measurement method, and a primary data source. Take a look at that first row, decentralization. We don't just guess at how many nodes are out there. We specify the indicator as validator distribution, the method as top-end concentration over a 30-day window, and the exact source as block explorers. The whole point is to measure the exact same things across architectures, rather than making up different bias tests for each one. And to make sure these measurements are actually repeatable, we have to rely on strict operational definitions. Think of these as the mechanical rules of your experiment. You need precise time windows, like strictly using a UTC-based 30-day period. You need entity identification strategies. Are you counting raw on-chain addresses or verified organization tags? And absolutely crucial here, you need predetermined rules for how to handle missing data. Because without these strict procedural mechanics in place, you and another analyst could look at the exact same protocol, get wildly inconsistent scores, and just completely ruin the reliability of your capstone report. We definitely don't want that.
All right, part 3, normalization and weighting. Let's solve the classic apples and oranges problem.
Here's the thing. Once you've actually collected all your data across these platforms, how do you mathematically combine, say, network latency speeds, which are measured in milliseconds, with user satisfaction, which might be measured on a 1 to 5 survey scale? You obviously can't add milliseconds to survey points. The answer is normalization. This is the process of scaling all those diverse indicator values into a common range, like 0 to 1, to allow for direct comparison. It lets us take totally different units and put them on the exact same mathematical playing field, all without losing the structural meaning of the original data. It's kind of magic.
So, the crucial point is, how do we actually do the math? Don't worry, it is way easier than it sounds. Here is the visual logic for min-max normalization. Step 1, just find the absolute minimum and maximum values in your dataset. Step 2,
take your specific value and subtract that minimum. Step 3, divide that by the total range, which is just the maximum minus the minimum. And boom, you've just converted a chaotic raw number into a clean, normalized score between 0 and 1. It is simple, elegant, and incredibly effective, even if you are entirely new to this kind of coding.
But wait, we aren't totally done with the math just yet, because once everything is normalized, we have to apply weighting. Now, weighting is basically the policy choice of assigning relative importance to different indicators before you combine them into a final composite score. Like, which metric actually matters more to your specific analysis. As a best practice, analysts should always run a baseline equal weight scheme, where everything is just treated completely equally, and then run a sensitivity-tested alternative with custom weights. This proves your conclusions are robust, even under different assumptions. Let's see how this actually builds a complete picture. In this sample weighting scheme, we've got node count driving 40% of the final score, data portability at 30%, and voting genie making up the last 30%. When you look at it this way, it becomes remarkably clear how your normative choices, what you personally decide is most important, directly impact the final output of your evaluation. Being super transparent about your weights is absolutely critical for your credibility.
Okay, part 4, scoring real-world cases. Let's put this into practice. It's time for the lab test phase, where we take these beautifully calibrated tools and apply them to the messy real world. Now what's really interesting here is how we can put 3 completely different generations of the internet side by side using the exact same measurement rules. We've got a static Web 1 site with 1 node, high data portability, and a 0 Gini coefficient. Then we contrast that with a centralized Web 2 platform, say 5 massive corporate modes, very low portability, and a highly unequal 0.9 Gini. And finally, a permissionless Web 3 protocol boasting 120 nodes, high portability, and a balanced 0.3 Gini. Applying the identical rules reveals vastly different architectural realities.
Now, to process all this efficiently, we typically use a simple automated grading machine, which is essentially just a basic Python script. This script takes our raw data set, handles all that min-max normalization math we just learned, applies our chosen weights, and then spits out a single, clean comparative score. And by the way, if you're interested in learning how to write these exact kinds of analytical scripts and really dive into the code, Forge College offers some fantastic learning programs that will walk you through it step by step. But for now, just know that the machine easily handles the heavy lifting for us.
And here it is, the final result of our engineering blueprint. These are the final weighted comparative scores for our Web 1, Web 2, and Web 3 archetypal cases. We have successfully done exactly what we set out to do. We've translated qualitative, VIB architectural differences into hard, defensible, and strictly comparable numbers. This right here is exactly the kind of evidence that makes a capstone report truly shine.
Finally, part 5, triangulation and trust. Quality assurance is key.
But hold on, we can't pop the champagne just yet. The truth is, a single metric from a single source can sometimes lie, or at least kind of misrepresent the whole truth. We absolutely must verify our work through triangulation. Triangulation is simply cross-checking your data by using multiple, independent sources to verify a measurement and reduce your bias. For example, you shouldn't just read a Web 2 platform's privacy policy where they claim you own your data. You need to pair that document inspection with an empirical lab test, literally attempt a data export yourself. When you combine what the document says with a real-world test, that's when you find the actual truth.
As part of building this trust, you also need to rigorously annotate your findings. Mark your data's confidence levels as high, medium, or low. If you have gaps or missing data, document them clearly. And always use conservative assumptions instead of just making up values to fill in a blank cell. I really want to stress this. Recording your measurement uncertainty isn't a weakness. It's the exact, rigorous practice that makes your capstone report bulletproof. Transparency is your greatest asset because reviewers are always going to trust an analyst who admits what they don't know far more than one who pretends they know everything.
So I want to leave you with this final provocative thought. If someone reran your code and your data pulls tomorrow, completely without you in the room, would they reach the exact same conclusion? That is the ultimate test of reproducibility. If the answer is yes, then congratulations. You have successfully operationalized your evaluation metrics. Thank you so much for joining me today. To dive even deeper into this subject and explore a wealth of other Web3 related topics, make sure to visit forge.college. Keep measuring, keep questioning, and I'll catch you in the next explainer.